Lesson 8-4, Graphing Rational Functions, Part 2. We're going to look at the second objective, to graph rational functions with oblique asymptotes and point discontinuity. Before we start, let's go ahead and review dividing. All right, when we divide a polynomial into another polynomial, we'll take this first term, x squared, and divide it by x. And that answer is x, which I'm going to put here on the x column. Now I'm going to multiply x times x, which is x squared, minus 8x. Now I'm going to subtract, and subtract means changing the sign. And so now I'm going to have x minus 11. And then I'm going to divide x divided by x, and that's going to be a plus 1. And so now I'm going to have x minus 8, and I want to change the sign. And then my answer is going to be negative 3. So here is my answer with my remainder. Let's do the same thing here. X squared divided by x, it's going to be x in the x column. X squared minus 6x. I want to change the sign. And now I'm going to get a 5x minus 29. I'm going to divide 5x by x. I'm going to get a positive 5. So that's going to be 5x minus 30. And now I'm going to change sign, and that's going to be a positive 1. Here's my answer with my remainder. Let's pause and let you try. And here are the answers. Let's take a look at an oblique asymptote, because it's what we call a slant asymptote. It's asymptote that is neither horizontal nor vertical. Now this happens when the numerator and the denominator differ by 1, where the numerator is 1 bigger in degree than the denominator. And that's what's happening over here. The numerator degree is 4, and the denominator degree is 3. When that happens, we can use division, and when we divide this answer, we disregard the remainder. That answer is what we call an oblique or slant asymptote, and that's what the curve wants to follow. It wants to follow this slant asymptote. Okay, let's go ahead and let's do an example where we do the graph. Let's find the zeros, and that's when the numerator is equal to 0. And that's going to happen at x equal to 0. So when x is 0, y is 0. Let's go ahead and graph 0, 0. Now we're going to try to draw the asymptotes. First, we want to graph the vertical asymptote, which is when the denominator is equal to 0. So that'll be at x equal to negative 1. Let's go ahead and draw the vertical asymptote. Now, because the degree of the numerator is 2 and the degree of the denominator is 1, we have a chance of having a oblique asymptote. And the way I find that is by dividing the denominator into the numerator. And I'm going to put a plus 0x plus 0. I'm going to write x times x is x squared plus x. I'm going to subtract. So now I have opposite of x plus 0. I'm going to divide. That's minus 1. And that's this. Minus 1. And then I'm going to change signs. And I disregard the denominator, and my oblique asymptote will be y is equal to x minus 1. The curve wants to follow that. So right here at negative 1, and then I'm going to go up 1 over 1, down 1 over 1, and then I'm going to have this oblique asymptote. We're going to let the calculator help us graph the rest of the part, and it's over here in my calculator, and then I'm just going to hit graph. And you can see that the graph wants to follow that asymptote. So I'm going to go over here, and it wants to follow this asymptote. And it wants to follow this by hitting this point right here. Okay, and so that's what the graph looks like. All right, let's do it again. Again, find our zeros. So we're going to set the numerator equal to 0. That's going to happen when x is 0, y is going to be 0. So we know it's going to go through the origin. Now we're going to look at the vertical asymptote, and the vertical asymptote will be x is equal to 2, because that's when the denominator equals 0. So we're going to write here, go ahead and draw the vertical asymptote. Now, since the degree of the numerator is 2 and the degree of the denominator is 1, this is a candidate for an oblique asymptote. So x minus 2, and we're going to divide it into x squared plus 0x plus 0. That's x squared minus 2x. I'm going to change signs, and that's going to be a 2x plus 0. And then this is going to be plus 2x minus 4, change signs, and I'm going to have a remainder of 4, which I disregard, and so the oblique asymptote will be y equals x plus 2. So I'm going to go over here at 2, I'm going to go up 1 over 1, down 2 over 2, and here's my other asymptote. Okay, we're going to let the calculator help us with the rest. I'm going to go to y equal. I'm going to turn this one off, and then I'm going to go ahead and turn this one on. That's the one I want. And I'll go ahead and hit graph. And you can see the graph wants to follow those asymptotes. So it wants to go along here, hit this, then go up and then down, and then it wants to hit that part right there. Okay, pause. Try to figure out all the important points before going to the calculator. And here's the answer. Okay, now let's talk about point discontinuity. Something very interesting happens when, after you do the factoring, you find you have common factors for the numerator and the denominator. When this happens, then the graph does not want to graph a vertical asymptote. It instead wants to graph what's left over if you were to reduce these by canceling these. And so it wants to graph just the leftover factor, but it creates a hole here where the denominator cannot equal 0. So that's kind of an interesting graph, which is called point discontinuity. Okay, let's do it again. We're going to take the numerator and we're going to factor. We're going to notice that we have common factors here. This is going to kind of reduce, and the graph wants to just graph this line, but it has a hole in it where in the original problem, x is not allowed to equal to 2. X cannot equal to 2. There will be a hole at it, not a vertical asymptote, but a hole. All right, let's take a look at starting again, and let's go ahead and graph. And I'm going to factor x plus 5, x minus 1, all over x plus 5. Now notice that we have a common factor, so the graph is going to want to graph this, x minus 1, the leftover factor, but x cannot equal negative 5. Right here, it's not going to be a vertical asymptote, it will be a hole. So let's go ahead and graph the line. It's going to be here at starting at negative 1, up 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. But when we get to 5, 1, 2, 3, 4, 5. So over here at 5, it's going to be a hole in it because we will have a graph for everything else except for this. Okay, the domain will be x such that x cannot equal negative 5. And then the range, well, what's the y that goes with this negative 5? So if I were to put negative 5 in here, then the point that goes with it is negative 6. And that's the point that I'm not going to get here. So y such that y cannot equal negative 5. Let's go to the calculator and let's see what it looks like. I'm going to change my zoom to zoom decimal. Now, it's hard for us to see -5. So I'm going to go over here to my window, and I want to change my y value. So I'm going to go over here and I'm going to times this y value by 2. And then I'll just go ahead and graph. And you can see there's a place where there's a hole right here. And that satisfies what we think is going to happen. Okay, pause and see if you can figure out what it looks like. And here's the answer.